All right, this video is going to be talking about variables on both sides of an equation and how we can solve equations with variables on both sides. Consider this scenario. Your sump pump has stopped working in the middle of the night. For those of you that don't know, most houses have a sump pump in your basement so that when it rains really hard and there's a bunch of water that's flowing kind of by the foundation of your house on the outside and it starts to leak in, it pumps it right back out so that you don't get any water in your basement. So this says your sump pump has stopped working in the middle of the night. You don't notice it until morning. By then there is already 210 gallons of water in your basement. Ugh. Water is entering your basement at a rate of 35 gallons per hour. You get a wet-dry vacuum and a replacement sump pump and are able to take out 95 gallons of water per hour. At this rate, how long will it take for all the water to be out of your basement, assuming water is still leaking in your old sump pump? Use the following equation to model this situation. So notice that we have this 95 gallons per hour that we are pumping out, and this is an amount of water, so I'm not worried about negatives or positives, okay? But I've got an amount of water that I am able to handle with my new sump pump as well as a wet-dry vac. I've got the rate at which this water is coming in still in the leak, and I've got the amount that I already had. So notice that I have an equation that has variables on both sides. So we'll get back to that problem in just a moment, but the more things change, the more they stay the same. So to move terms or numbers or variables from one side of an equation to the other, it's not different than it ever has been. So for example, if I have this equation 3x equals 2x plus 5, and I want to bring this 2x over here to be on the same side as the 3x, notice that this is an addition problem. And so I'm looking at the sign of 2x. It is currently positive. And so to cancel it on this side, because I don't want it to be on this side of my equation anymore, I want it to be on this side with my like terms. So notice that I'm taking this positive term and I'm subtracting it so that on this side these cancel. And then I've got 3x minus 2x is going to be just 1x. Would equal 5, and I've actually solved that equation just by moving that piece over to the other side. So if you're stuck and you don't know what to do for sure, here's a way that'll always work. So you can move all your variables to the left side of the equal sign, and then you're going to move all your numbers to the right side of the equal sign, and then you're going to solve kind of like we already have been. So let's take a look at an example. Solve the equation. So just like we said on the previous slide, I'm going to take this 4x, which is on the right side of my equal sign. So notice this equal sign is still trying to keep everything in balance, okay? So whatever I do to this side, I need to do to this side. But I want to take this 4x piece and I want to move it over here so that it's with its like term, so that I can find out what x is. So this 4x right now is positive, so I need to subtract it. And what we notice is these cancel, which was good because I don't want it to be located over here anymore. I want it to become 0. Over here, when I simplify, 6x minus 4x, those are like terms, and that is just 2x. I still have plus 13 equals 23. Now, just by moving this x term over to here, I now have a two-step equation that we're used to solving. So a lot of times it only takes one step for me to get this back to something that looks recognizable. And now I'm going to move my number, which is not my variable, to the other side so that it's with its like terms. And so I'm kind of grouping like terms on opposite sides of the equal sign. And now that I'm down to this step, I'm just going to solve like normal. So 2x equals 10. I'm going to divide both sides by 2. And x will equal 5. So just to recap, I want to get my like terms together. I took my 4x from the right side, I subtracted it to get it to the other side because it was positive. I had to do the opposite, and I did it to both sides. It canceled, and I brought my x term over to here. And then I want to get my number with its like term on the other side. So it was also positive, so I had to subtract it. And then I am left with just this equation that I know how to solve. and I can, in this case, do division to solve for it. So go ahead, I want you to practice this one on your own, and when you're ready to see the answer, you can go ahead and hit play. So this one is, first of all, got some like terms in it on the left side, so I want to simplify those before I start to solve anything at all. Okay, so I've got 14p minus 8p is going to be 6p plus 7 equals 13 plus 4p. And again, I want to get this p term right here so that it's with its like term on the other side of my equal sign, so I need to subtract it because it's positive 4p. So I will subtract it, and these are going to cancel. I've got 2p plus 7 equals 13, and I want to get my numbers that are not variables on the right side so that they're all with their buddies and their like terms. So 13 minus 7 is 6, and now I can divide, and I've got p equals 3. And remember, if you're checking these out, you can always go back to the original, you can plug in your answer, and you can check your answer to make sure that you've got it right. So now let's solve this scenario that we started out with at the very beginning. We've got our sump pump again, it's not working. Water is leaking in at 35 gallons per hour. There's already 210 gallons down there. So we've got that represented right here. We figure out the problem, there's a leak, and we get a new sump pump plugged in, and it's pumping water out. We also have a wet dry vac, and we're trying to clean up the carpet and everything, and we're taking water out at 95 gallons per hour. And so if I want to solve this to figure out how many hours that it's going to take for us to get all the water out so that we are currently catching up, I'm going to solve this. I'm going to bring this 35x to the other side so that it's with its buddy. And I now have 60x equals 210. I'm going to divide, and x is going to equal 3.5 hours. So in 3.5 hours of working on getting the water out of your basement, even though water is still leaking in, you're going to be able to keep up because you have the fact that you are draining more out than you are allowing in at the leak until you can get a plumber there to fix it. Okay, so here's just a scenario of how we might have variables on both sides, and we're going to be solving equations then that have variables on both sides.